Hello, I'm Ruby. In this video, we will see what net charge is. Additionally, we will represent ions and classify them as cations and anions. We must know the ways we represent atoms and obtain the numbers of protons, neutrons, and electrons in the atoms. We can see some representations on the screen, with their atomic numbers, their mass numbers, and their chemical symbols. Often, we find something called net charge within this symbolism. In atoms, the net charge is zero. For this reason, we don't write it. When the net charge is not zero, we are representing ions. If the net charge is positive, we have a positive ion and we call it a cation. On the other hand, if the net charge is negative, we have a negative ion and we call it an anion. The net charge equals the number of protons minus the number of electrons. A neon atom has the same number of protons and electrons. Therefore, its net charge is zero. And when the net charge is zero, we don't write it. A beryllium cation has a net charge of +2. This means this ion has 2 more protons than electrons. In the cation representation, we write the number 2 first and then the plus sign. A chlorine anion has a net charge of -1. This means this ion has 1 more electron than protons. In cases where the net charge is 1, we don't write the number 1. We only write the sign. Now, we know what net charge is. Now, we see 2 representations of a helium atom on the screen. We will use a simple scheme to visualize atoms according to Bohr's atomic model. The circle represents the atom's nucleus, and the arcs represent its orbits. Let's compare a lithium atom with a lithium cation. Their atomic numbers indicate the number of protons. Both have 3 protons. We obtain the number of neutrons by subtracting the atomic number from the mass number. Both have 4 neutrons. The net charge of the atom is 0, meaning there are 3 protons and 3 electrons. While in the lithium cation, the net charge is +1. When the net charge is not 0, we obtain it by subtracting the atomic number from the net charge. 3 minus 1 equals 2 electrons. Now, let's compare a fluorine atom with a fluoride anion. Their atomic numbers indicate that both have 9 protons. We subtract the atomic number from the mass number and find that both have 10 neutrons. The net charge of the atom is 0. Therefore, it has 9 protons and 9 electrons. In the fluoride anion, the net charge is negative. We subtract the atomic number from the net charge. 9 minus -1. Remember that minus a negative is positive. This way, we find that the ion has 10 electrons. Now, let's do the following exercise. Let's calculate the number of protons, neutrons, and electrons for each ion. The sodium cation has 11 protons, 12 neutrons, and 10 electrons. The chlorine anion has 17 protons, 18 neutrons, and 18 electrons. The magnesium cation has 12 protons, 12 neutrons, and 10 electrons. The oxygen anion has 8 protons, 8 neutrons, and 10 electrons. In the next video, we will look at Bohr's atomic model. See you later. Bye.